Yeah.
It's all good. It's all good.
Thanks, Taylor, for joining us.
Yeah, for sure. Sweet. Now it looks like our TA is on.
She was there for a second, right?
Yeah, I don't know if. Oh, sweet, sweet, perfect. Sounds good then. And then Micah, this is the first time you've been in our group, right?
Correct. Yep. First time.
Thank you, Micah.
Sweet, man. Good to have you.
Us.
I probably shouldn't let you know, but math is my weakest subject. So.
Oh man.
Excellent.
Perfect.
We work well together.
Mine too.
So.
All right.
All right.
Okay.
Anybody have questions about this week's stuff?
It seemed pretty straightforward.
Let's see.
No, I can't hear you. Can you hear us?
Oh, can you hear me?
I can hear Micah. I can't hear our TA. She just typed to say she doesn't have a camera, but she said she's got audio.
Yeah, I can't hear the TA either.
Okay.
Love technology.
It's great when it works.
It is. Some of it I'm still figuring out, so.
It's all good. All good.
So Micah, where are you from?
I'm actually from Pennsylvania.
Oh yeah?
Driving in Pennsylvania.
Oh, nice. Yeah, I'm from a little town called Spring Grove.
Okay. Well, I just see an exit for Morgantown.
Okay.
We're on our way to DC for a convention.
Very nice. Are you going to the DC temple at all?
We don't have time to do that, unfortunately.
Oh, okay. Maybe next time.
We're done here Friday, and then it's hurry home because our son leaves on his mission on Monday. And so we have a quick open house and, just a couple days with him before he leaves, and he's gone. So we didn't have time to stay in DC and do. But that's all right. It'll be a good trip.
Yeah, it sounds like you've got a full calendar or a full schedule for sure.
Yep. Okay, so, let's start talking about this week's stuff.
Sounds good.
Any questions?
None from me for now.
Yeah, like I think I was kind of having questions with how to figure out if it's like normal or skewed right or whatever. But then I just kind of did a refresh just earlier, and it made sense kind of going through a second time. So yeah, I think I'm good.
Okay.
Should we start on the quiz?
Yeah. Hopefully this works. I'll try to pull it up.
Can you guys hear me?
Yeah, I think so.
Yeah, I can hear you now.
Awesome. Cool.
Okay. And then Christine, I think it's kind of breaking up, but I'll just read them.
I'll
And then
try to follow along and just offer input where I can.
no,
Okay.
for sure, yeah. And I bet if you can't access the quiz or something, you know, if you're following along, you can probably just go in later or something. Whatever works for you.
Sounds good, guys.
Okay. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? I would think it would be
Skewed
It'd be
right?
skewed as well, right?
yeah. Yeah. Sweet. And then
Okay.
is that the thing where it says like n5 or less, and then like would mean it's not normal, and then like n more than 30 is normal? Is that what it was saying?
I think it was saying that if n equals 5, it'll be approximately normal. If we have less than 5, then we don't really know. But as long as it's 5, but if it's 30, then it's sufficient to be normal.
Oh, okay.
So it'd be approximately normal,
Gotcha.
right?
The borderline is 30.
If n is 5, the graph would be normal, or would it still skew like the population? Or
So if it's less than 30, then it will follow whatever pattern the parent population is. So if the parent population skews right, then
okay, so we were right.
Gotcha.
It was skewed right.
Very good.
Okay, yeah, that makes sense. Okay, when you're taking a
All right.
sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed?
That would be normal, wouldn't it? Be
I
bell-shaped?
would think so, yeah.
Yeah, because it's
the
over
more
30.
Mm-hmm.
The
Yeah,
larger the size, the even more it goes towards that bell shape.
for sure, yeah.
Yep.
All right, Micah, do you want to read?
Yes, sir. All right. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
That'd be normal, right? Because
Is.
whenever the parent is, or
That would be my guess. Yeah. You think it's normal?
I think so.
It's going to follow the parent.
Okay. All right.
Whatever the parent.
I'll read number 6 then if we're ready.
California.
Okay.
All right. So number 6 is when you are taking a sample size of n equals 100, what is the shape of distribution of means histogram when the parent population is normally distributed? Yes. That's what I believe. Yep.
Yeah.
Because it's greater than 30. That's the reasoning, right?
Well, and then, that, and if the parent population is normal, then it's always normal. So
Right.
I think both of them shows it.
Okay.
All right.
All right. When would the distribution of means be normally distributed? Choose all correct responses. Data are drawn from a population that is normally distributed and the sample size is small. Drawn from a population that is normally distributed and the sample size is large. Drawn from a population that is right skewed and the sample size is small. Drawn from a population that's right skewed and the sample size is large. So I think both
A large sample, large.
of the large samples, yeah, and then where the population is normally distributed.
So there were 3 of those, right, that you're clicking on?
Yeah.
I believe it was the first,
Okay.
the second one, and the last one, right?
Yeah.
Okay. But
Yeah, that's what I think.
that makes sense to me.
Okay. Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. For bell-shaped data, approximately 68 of the data, whatever, 68, 95, 99.7. If the sample size is large, the sample mean will be close to the population mean. If the sample size is large, the shape of the distribution of sample means will be approximately normal. So I know it's not the 68 whatever. That's a different rule.
Yeah. The sample size is large. The shape of the distribution means will be approximately normal.
Okay, yeah. That's the one I was leaning towards.
Okay. I'm good.
Okay. Let's see. All right, I'll read the next one if that's okay.
Thank you.
All right. Use the following information to answer the next 4 questions. Let X be a random variable with population mean, let's just call that U equals 10, and population standard deviation O equals 6. Suppose the sample size N equals 36 is drawn from this population. Number 9. What is the mean of the distribution of sample means?
That one's going to be
It's
10.
Wouldn't it be
gonna be
10?
10. It's the same mean.
Yeah, it's identical.
Right.
Yeah.
All right. What is the standard deviation of the distribution of sample means?
6 divided by the square root of 36. Is that where that one fits in?
I think so, yeah.
Yes. So the standard deviation of the parent population divided by the square root of the sample size. So it's going to be 6 divided by
449. Is that what you're getting?
6 divided by the square root of 36.
Oh. Never mind. I just popped in 6. I was missing the 36.
Wouldn't it just end up being 6 and with
Say that again.
Oh, duh, because it'd be 6 divided by 6. So it's just 1.
right?
Okay. Gotcha.
And number 11 says.
I thought you said you weren't good at math, Micah.
And it really depends. Usually like algebra.
I'm teasing. Okay, let's go on.
All right, regardless.
I still have nightmares of algebra to this day. But anyways, number 11, list of the distribution of the population. If the sample size is large, n is greater than 30, what would the shape in parentheses distribution of the sample mean?
It would be normal, right?
Yeah.
Just a question. I feel like it's normal, but I'm not sure.
No, yeah, that's what I think too.
Because it's greater than 30,
Right.
Yeah.
right?
Yeah.
No, yeah.
So the
I feel
sample
like
size is large.
this
So that,
quiz is like eerily. It's kind of eerie, but
All right.
easy. So, what
and that
theorem
has
would
to do with
justify your response?
the law of large numbers, right?
Right. Yep.
Okay.
And number 12 is the last one, I believe. It says, what theorem would justify your response to the last question? Last question. Law of large numbers?
I said it and I didn't even
Look
have
at
the
that.
question.
You connected the dots before we even got there.
Love it. Because I was actually quite confused last night, and I thought when we go through this quiz, it's going to start to make sense. I know it is, right? So it's going to make sense.
Oh, well, hold on.
Exactly.
No?
So I just submitted it, and it said the last one is actually central limit theorem.
Oh, that's interesting.
Are you kidding me?
Man, right when you were just starting to get a little bit of it, Christine.
You mean I was getting full of pride? Okay, so
Oh, actually, now that I read the definition of central limit theorem, that actually makes sense. It says as the sample size n increases and becomes large, the distribution sample means becomes approximately normal. So I guess that makes sense.
so what's the law of large numbers then? I gotta look that up again.
That one says as the sample size n increases, the sample mean x draws closer to the population mean.
Oh, right. Okay.
Okay, so the
central
mean
limit theorem is
gets
just
closer.
we're going to get a huge range, and then law of large numbers is okay. But most of them are going to be in the middle.
Okay.
Right?
Yeah,
Is that what
so
it's saying?
the central limit theorem is describing the spread, like the distribution of the sample mean distribution. But the law of large number is describing the mean of the
Oh, it's only
sample.
focusing on the mean is what the law of large numbers is, right?
Yeah. So I kind of
Okay,
remember it
gotcha.
because the law of large number has the word number, like mean. But the central limit theorem is like interest, like
In
describing
2 miles,
the
7A
distribution
to merge
pattern.
onto P43 south toward California.
So it's related to
Okay.
the spread
Makes sense.
pattern.
Okay, sweet. Yeah.
Good thing we can take it again, right? Is that the only one we missed?
Yeah.
Okay. Excellent.
Well done.
Okay.
Good job.
All right, so Thursday I should be in a classroom somewhere and be able to just not have internet issues, hopefully, and be
Okay.
good
Yeah.
to meet. Okay?
I think are we all going to be meeting together tomorrow for our like big class meeting? Is that all of us meeting or how does that work?
Yeah, and I'm hoping to be able to get to that. I don't know for sure if I will, but I'm going to try.
Okay. Do we lose points or anything if we are unable to attend?
It sounded to me like it was optional, but
Okay.
maybe I'm wrong.
Okay. Cool. Because I get off work at like 8, so I was a little concerned about my scheduling.
That would make it tricky.
Yeah. But yeah. Okay. Cool. Any questions or anything before we go our separate ways?
I think I'm good.
I'm good so far.
Thank you for
You guys
letting
are,
me
yeah.
join you.
Thank you
Thanks
for
so
your
much
help.
for joining
Christine.
us.
All right, we'll
All
see you
right.
Thursday.
See everybody
See you
Thursday.
guys. Bye.
Bye.